Today let's look for the unit 3 of dynamical systems, the MCQs. The orbit nu is the omega limit set of every point except dash, and the origin is the dash of every point inside nu. So the correct option over here is given. Options given are origin, omega limit set, origin, alpha limit set, either A or B, none of these. So the correct option over here is B, origin and alpha limit set. Now let's see, Tn means Tn is a sequence of times. We know the definition of omega limit set and alpha limit set. Alpha limit set moves towards the negative infinity and omega limit set moves towards the positive infinity. So let's see, the orbit nu is the omega limit set of every point except the origin. Okay, so towards like this. And for alpha limit set, it will move on, and the origin is the alpha limit set of every point inside nu. So the point will go on towards here, so origin. Okay, next, a limit set contains dash set of every point in it. Alpha limit set, omega limit set, both alpha limit and omega limits, and none of these. So the correct option is both alpha limit set and omega limit set. We know the thing that a closed invariant set, in particular a limit set, contains the alpha limit and omega limit sets of every point in it. Next, these two were concerned from the limit set section. Now next, a local section at O of f is dash S containing O in a hyperplane H contained in E. Now the hyperplane H contained in E, this is the hyperplane H. The correct option over here is an open set. It is an open set. S is an open set. This has been transformed towards this. So hyperplane is converted into this local section at O. O is this O, transferred O. And this phi or psi is a diffeomorphism, and diffeomorphism is itself a flow box. Okay, it is a mapping. Flow box is a mapping. Moving on to the next. If S is a local section, dash through a point Z0, perhaps far from S, may reach O belonging to S in a certain time T0. This is the local section S, this is O. Phi t of T0. Now phi t of T0 of Z0, Z0 is this. So this is the trajectory. Phi is for trajectory. Time T0. In time T0, the Z0 would go from here, here, and phi t of 0 is a trajectory Z0, which equals at the origin, which equals the origin. Let S be a local section of a C1 planar dynamical system. S be a local section of a C1 planar dynamical system, and y0, y1, yn. y0, y1, so y2, yn will be like this. A sequence of distinct points of S that are on the same solution curve C. This is the solution curve, and it will go on like this. Okay. So then dash, if the sequence is monotone along S, it is monotone along C. If the sequence is monotone along C, it is also monotone along S, either A or B, neither A nor B. So the option is, if the sequence is monotone along this curve C, then it is monotone along S. Next, let y belongs to L omega of x union L alpha of x, then trajectory of y crosses any local section at more than one point. Trajectory of y do not cross any local section. Trajectory of y crosses any local section at not more than one point, or either A or C. The correct option is C. So this and the back one MCQ was from the flow boxes and local section, and these two were from the monotone sequences in a planar C1 dynamical system. Okay. Now the last four. A non-empty compact limit set of a C1 planar dynamical system which contains no equilibrium point is a closed orbit. This is the statement of Poincare-Bendixson theorem. Next, from Poincare-Bendixson theorem, it is clear that a compact limit set which contains no limit point is either a alpha limit cycle or a omega limit cycle. This is same statement, just either a alpha limit cycle or omega limit cycle. This is the application of Poincare-Bendixson theorem. Next, let gamma be a closed orbit enclosing an open set U contained in the domain W of the dynamical system. Then U contains local section, positively invariant set, negatively invariant set, or equilibrium. This is equilibrium is the answer. This is again the application of Poincare-Bendixson theorem. Now the last one, this system of two simultaneous differential equation describing predator-prey model in ecology is called as x dash of t a minus b by x of t, y dash of t equal to cx minus dy of t, abcd greater than 0. This is mainly called as Volterra-Lotka equation. Okay, so again I am saying that these aren't the MCQs which will appear, it's just my point of view. Thanks for watching.